Tonight, we will spend a little time with birds. We will move slowly through 30 quiet facts about their bodies, their senses, their journeys, and the many ways they live across the world. Some birds cross oceans. Some remain within the same small patch of forest for their entire lives. Some sing before sunrise, while others move silently through the darkness. You do not need to remember any of this. You can simply listen as the facts pass by. And if sleep arrives before the final one, you can let it arrive. Fact 1. Birds are living dinosaurs. Modern birds belong to the same large evolutionary group that included dinosaurs such as Velociraptor and Tyrannosaurus. They did not merely appear after the dinosaurs. They are one surviving branch of the dinosaur family tree. The closest fossil relatives of birds were small, feathered theropod dinosaurs. Many of these animals had hollow bones, wishbones, three-toed feet, and feathers. Some could glide. Others probably used their feathers for warmth or display rather than flight. About 66 million years ago, a mass extinction ended the age of most dinosaurs. A few small bird-like lineages survived. Their descendants gradually spread into forests, wetlands, deserts, mountains, and oceans. So when a pigeon walks across a pavement, it carries a very ancient inheritance. Its feet, feathers, posture, and light skeleton all preserve traces of a history that began long before humans existed. Fact 2. Feathers probably evolved before powered flight. Feathers are strongly associated with flying, but their first purpose may have been different. Fossils show that many dinosaurs had feathers even though they could not fly. Early feathers were simple structures. They may have helped animals retain body heat. Later forms became more complex and colorful. They could be used for camouflage, courtship, protection, or communication. Only after many stages of evolution did some feathered animals begin using their limbs to glide and eventually to fly. Flight feathers became asymmetrical, with one side narrower than the other. This shape helps control the movement of air. Modern birds still use feathers for much more than flight. Feathers keep them warm, shed water, protect the skin, produce sound, and create visual signals. A bird may raise its feathers to appear larger, flatten them to reduce air resistance, or fluff them to trap a quiet layer of warm air beside the body. Fact 3. A bird's bones are light, but they are not simply empty. People often say that birds have hollow bones. This is partly true, but it can give the wrong impression. Many bird bones contain internal struts and braces. These structures make the bones strong while keeping their mass low. Some bones are connected to the respiratory system and contain air spaces. These are called pneumatic bones. They are especially common in larger flying birds, although the pattern varies between species. A light skeleton helps with flight, but strength is equally important. The bones must tolerate the force of wing beats, takeoffs, landings, and sudden turns. Several bones are fused together, creating a rigid frame. The large breastbone of many flying birds has a deep ridge called a keel. Powerful flight muscles attach there. Not every bird has the same arrangement. Penguins have denser bones that help them dive. Flightless birds such as ostriches have reduced keels. The skeleton of each species reflects the way that species moves through its world. Fact 4. Birds breathe differently from mammals. Human lungs expand and contract as air moves in and out. Bird lungs remain relatively fixed. A system of air sacs helps move air through them. The exact pathway is complex, but the result is a mostly one-way flow through the gas-exchanging parts of the lungs. Fresh air can continue passing through during both inhalation and exhalation. This is useful because flight requires a great deal of oxygen. The muscles must work continuously, sometimes for many hours. Birds also need efficient breathing at high altitude where the air is thin. The air sacs extend into parts of the body and sometimes into the bones. They do not perform most of the gas exchange themselves. Instead, they act more like bellows, keeping air moving. This system is one reason birds can sustain forms of activity that would be difficult for many mammals of similar size. Even while a bird appears to glide calmly above the ground, its respiratory system is maintaining a steady and carefully organized flow. Fact 5. Many birds have extremely high body temperatures. The normal body temperature of many birds is around 40 to 42 degrees Celsius. This is warmer than the typical temperature of a human body. A high temperature supports a rapid metabolism. Flying, maintaining feathers, finding food, and staying alert all require energy. Small birds lose heat especially quickly because they have a large surface area compared with their body mass. To conserve warmth, birds fluff their feathers and reduce blood flow to exposed parts. Some tuck one leg into their plumage, others rest with the bill placed beneath the feathers of the shoulder. At night, a few small species enter a state called torpor. Their temperature and metabolic rate fall for several hours. This reduces energy use when food is scarce or nights are cold. By morning, the bird must warm again. The return to full activity may take only a short time, and soon the small body is moving, feeding, and producing heat once more. Fact 6. A hummingbird's heart can beat more than 1,000 times per minute. Hummingbirds are among the smallest birds, yet their bodies operate at remarkable speed. During active flight, the heart of some species may beat more than 1,000 times in a single minute. Their wings can beat dozens of times per second. Instead of only pushing downward, the wings rotate through a figure-8 pattern. This allows hummingbirds to produce lift during much of the wing stroke. They can hover in one place, fly sideways, and move backward. This control helps them feed from flowers while remaining in the air. Such activity demands frequent food. Hummingbirds drink nectar for rapid energy and also eat small insects for protein and other nutrients. At night, many hummingbirds lower their metabolism through torpor. Their heart rate slows, their temperature falls. The temperature falls. The temperature falls. The tiny bird becomes still. As daylight returns, it gradually warms and wakes. Soon the wings begin moving again, and the quiet pause of the night gives way to another day of rapid, precise flight. Fact 7. Owls can fly with very little sound. An owl's silence comes partly from the structure of its feathers. Along the leading edge of the wing, some feathers have comb-like projections. These break the air into smaller currents and reduce turbulence. The trailing edges of the feathers are soft and fringed. The upper surfaces are covered with a velvety texture. Together, these features reduce the noise normally created as air passes over a wing. Silent flight helps an owl approach prey without warning. It may also help the owl hear faint sounds while it is moving. Not every owl hunts in the same way. Some wait on a perch, others fly low over grasslands. Many rely on both sight and hearing. The price of quiet flight is reduced aerodynamic efficiency. Owl feathers are not built for the fastest possible movement. They are built for control and silence. In the darkness, a hunting owl may pass overhead with almost no sound, leaving only a brief movement of air before the night becomes still again. Fact 8. Some owls have ears at different heights. The openings of an owl's ears are often hidden beneath feathers. In several species, one ear opening is positioned higher than the other. This uneven arrangement helps the owl locate sounds in 3 dimensions. A noise may reach one ear slightly earlier or with a slightly different intensity. The brain compares these differences. The facial disc also helps. Its curved feathers guide sound toward the ears, somewhat like a shallow dish. An owl can use this information to estimate whether a sound comes from the left or right and whether it comes from above or below. Some species can detect small animals moving beneath leaves or snow. The owl may pause, turn its head, and listen. Then it adjusts its position before striking. This process happens quickly, but it depends on tiny differences in sound. In a dark forest or open field, those differences form a kind of map. The map is invisible yet detailed enough to guide the bird toward a hidden source. Fact 9. Birds see colors that humans cannot see. Human eyes usually have 3 types of color-sensitive cone cells. Many birds have 4. The additional cone is often sensitive to ultraviolet light. This means that a bird may see patterns that are invisible to us. Feathers that appear plain may reflect ultraviolet light in ways that communicate age, condition, or sex. Some fruits, flowers, eggs, and trails left by small animals also reflect ultraviolet wavelengths. The value of this ability differs between species, but it can assist with finding food and choosing mates. Bird eyes often contain tiny colored oil droplets inside their cone cells. These droplets filter light and may improve color discrimination. We cannot know exactly what this visual world feels like to a bird. Human descriptions are limited by human senses. Still, it is clear that many birds live in a world with more color information than we receive. A quiet garden that looks green, brown, and gray to us may contain additional signals, visible only through another kind of eye. Fact 10. A bird's eye may be larger than its brain. In some species, the eyes occupy a very large part of the skull. This is especially noticeable in birds that depend heavily on vision. Large eyes collect more light and can produce detailed images. Eagles and other raptors have excellent distance vision. Owls have large eyes adapted for dim conditions. Bird eyes are often less spherical than human eyes. Their shape is supported by a ring of small bones called the sclerotic ring. Many birds cannot move their eyes very far within their sockets. Instead, they turn the head to change their view. This is one reason bird head movements can appear so quick and precise. The position of the eyes also matters. Birds with eyes on the sides of the head have a wide field of view. Predatory birds often have more forward-facing eyes, creating stronger depth perception. Each arrangement is a compromise. A bird's visual system reflects what it needs to notice, whether that is a distant animal, a nearby seed, or movement approaching from behind. Fact 11. Most birds do not have a strong sense of smell, but some have an excellent one. For a long time, people assumed that birds relied very little on smell. This is true for some species, but not for all. Vultures in the Americas can detect gases released by decaying material. The turkey vulture may follow these scents through forests where the ground is hidden by trees. Kiwis search for worms and insects in the soil. Their nostrils are located near the tip of the bill, which is unusual among birds. Petrels and albatrosses can detect chemical signals associated with productive areas of the ocean. These scents may guide them toward food across large distances. Some seabirds also use smell to locate their nesting burrows after returning from the sea. The bird world contains many different sensory arrangements. Vision dominates in numerous species, but smell can become important where food is hidden, where nights are dark, or where the landscape has few obvious landmarks. A faint odor moving through the air may carry enough information to guide a bird home. Fact 12. A woodpecker's head is adapted for repeated impact. A feeding woodpecker may strike wood many times in a short period. Its skull, beak, muscles, and posture work together to manage these impacts. The beak is strong and shaped to transmit force. The neck muscles guide the movement. The skull contains structures that help distribute mechanical stress. The brain fits tightly inside the skull, reducing the amount it can move after each strike. The bird also hits the surface in a controlled direction rather than with random motion. Woodpeckers do not strike only to find insects. They also create nesting holes, store food, and produce drumming sounds used for communication. Their tongues are highly specialized. In some species, the tongue can extend far beyond the tip of the bill. Supporting structures curve around the back of the skull. The entire system is built around repeated, accurate movement. A woodpecker may pause between bursts, listen quietly, adjust its feet, and then begin tapping again the same piece of wood. Fact 13. A bird's beak continues to grow. A beak is covered by keratin, the same general material found in human fingernails and hair. This outer layer slowly grows and is worn down through normal use. Birds use their beaks for feeding, cleaning feathers, building nests, defending themselves, and caring for young. Each activity produces wear. The shape of a beak reflects a bird's usual diet. Hawks have curved beaks for tearing. Ducks have broad bills that help filter food from water. Finches have strong, compact beaks for handling seeds. A beak is also sensitive. It contains nerves and blood vessels, especially near the base. Some birds have touch receptors that help them locate food in mud, sand, or soil. Because the beak grows continuously, damage or abnormal wear can cause serious problems. A healthy bird normally keeps it shaped through everyday behavior. The beak may look like a simple hard tool, but it is a living, growing structure used with great precision throughout the day. Fact 14. Birds spend a large amount of time caring for their feathers. The regular cleaning and arranging of feathers is called preening. A bird runs individual feathers through its beak, removing dirt and parasites while reconnecting small structures that hold the feather together. Many birds have a preen gland near the base of the tail. It produces an oily substance that the bird spreads through its plumage. The exact purpose varies, but it can help maintain feather condition and may reduce the growth of some microorganisms. Birds also bathe in water, dust, sunlight, or even ants. These behaviors can help control parasites and keep the feathers usable. Feather care is essential for flight and insulation. A small gap in the plumage may allow heat to escape. Damaged flight feathers can affect balance and efficiency. Preening often occurs during quiet periods. The bird settles on a safe perch, turns its head, and works slowly across the body. Feather by feather, the smooth outer surface is restored. Fact 15. Birds must replace worn feathers. Feathers are dead structures once fully formed. They cannot heal in the way skin can. When they become worn, they must be replaced through molting. During a molt, old feathers fall out and new ones grow from follicles in the skin. Growing feathers contain blood and are sometimes called blood feathers. The timing differs between species. Many birds molt after breeding. Others replace feathers before migration or before developing bright breeding plumage. Most flying birds do not lose all their flight feathers at once. They replace them in a sequence that allows continued flight. Ducks and some other water birds are different. They may lose many flight feathers together and become temporarily unable to fly. Growing feathers requires protein and energy. Birds may become quieter or more secretive during this period. A newly grown feather is smooth and complete. Over time, sunlight, movement, and contact slowly wear it down. Eventually another molt begins, and the quiet cycle of replacement continues. Fact 16. Some birds sleep with one half of the brain more awake than the other. This state is called unihemispheric slow-wave sleep. One half of the brain enters deeper sleep while the other remains more alert. The eye connected to the more active half may remain open. This allows the bird to watch for danger while still receiving some rest. Ducks at the edge of a group are more likely to use this form of sleep than ducks protected in the center. The outer birds often keep the eye facing away from the group open. Some migrating birds and seabirds may also use partial sleep during long periods of movement, although the details vary and are still being studied. Bird sleep is flexible. Some species sleep in short episodes. Others gather in communal roosts where many individuals share the task of remaining alert. If you are still with me, that is perfectly fine. There is nothing to follow closely. We can simply rest beside this image of a quiet group of birds, some sleeping deeply and some keeping one calm eye open. Fact 17. A few birds can sleep while flying. Great frigate birds have been recorded sleeping during long flights over the ocean. Small instruments attached to the birds measured their brain activity. The birds slept for only brief periods and far less than they normally sleep on land. They sometimes use one half of the brain at a time. At other moments, both halves entered sleep together for a short while. Most of this sleep happened while the birds were circling upward in rising air. During gliding descents, they were more likely to remain awake. This does not mean that all birds routinely sleep in flight. The behavior is difficult to study, and it probably depends on the species and the demands of the journey. Frigate birds can remain over the ocean for days or weeks. They use air currents to travel with limited flapping. Far above the water, the wings remain spread. The bird follows the moving air, and for a few seconds, parts of the brain become quiet. Fact 18. Bird migration can cover the length of the planet. The Arctic tern travels between northern breeding grounds and southern oceans. Over a full year, some individuals may cover distances greater than 70,000 kilometers. The route is not a straight line. The birds follow winds, food, coastlines, and ocean systems. Their journey carries them through more daylight than almost any other animal experiences. Other migrants make equally demanding trips. Bar-tailed godwits can fly across large sections of the Pacific without stopping to feed. Small songbirds cross seas and deserts despite weighing only a few tens of grams. Before migration, birds store fat. Fat contains more energy per unit of mass than carbohydrates or protein. Some birds greatly increase their body weight before departure. During the journey, they may travel by day or by night. They rest in wetlands, forests, fields, and coastal areas. Migration is not one's forests, fields, and coastal areas. It is a vast collection of routes, repeated by generations, each shaped by weather, geography, and inherited timing. Fact 19. Birds can sense Earth's magnetic field. Many migrating birds use several navigation systems at once. They follow the sun, stars, coastlines, odors, and familiar landmarks. They can also detect information from Earth's magnetic field. The exact biological mechanism is still being studied. One idea involves light-sensitive proteins in the eye. These proteins may help birds perceive magnetic direction as part of their visual experience. Another possible mechanism involves tiny magnetic particles in tissues connected to the nervous system. Young birds of some species can follow an inherited general direction during their first migration. Older birds often refine their routes through experience. Magnetic information is useful when clouds hide the sun or when the landscape offers few clear features. It does not act like a simple human compass. It is probably combined with other signals. A migrating bird moves through several overlapping maps. Some are visible, some are remembered, and one may come from the faint magnetic structure surrounding the entire Earth. Fact 20. Young birds can learn the night sky. Some songbirds migrate at night and use the stars for direction. Experiments in planetariums have shown that young birds learn the pattern of rotation around the northern sky. They do not simply memorize one bright star. Stars shift with the seasons, and some may be hidden by clouds. The important clue is the apparent center around which the sky turns. A young bird exposed to an artificial sky can adjust its orientation according to the pattern it has observed. This learning occurs before or during the period when migration begins. The stars are only one part of navigation. Birds also use magnetic cues, sunset direction, winds, and landmarks. Night migration offers several advantages. The air may be cooler and calmer. Predators may be less active. Daylight can then be used for feeding. Above a sleeping landscape, many small birds pass almost unnoticed. Their calls are brief, their silhouettes are faint, yet they are following patterns of light that humans have also watched for thousands of years. Fact 21. Albatrosses can travel with very little flapping. Large albatrosses have long, narrow wings. They use a technique called dynamic soaring to extract energy from differences in wind speed above the ocean. Close to the water, the wind is slowed by friction. Higher above the surface, it moves faster. The bird repeatedly climbs into stronger wind, turns, and descends toward the waves. By following this looping path, an albatross can travel long distances while using relatively little muscular effort. It may cover hundreds of kilometers in a day. The wings are so well suited to gliding that continuous flapping would be expensive. Some albatrosses have a mechanism that helps hold the wings open without constant muscle tension. They spend much of their lives over open water and return to land mainly to breed. Seen from a distance, the bird may appear almost motionless. The ocean moves beneath it. The wind changes with height, and the albatross quietly borrows energy from those invisible layers. Fact 22. Penguins use their wings to fly through water. Penguins cannot fly in air, but their movement underwater closely resembles flight. Their wings have become stiff flippers that produce lift as they sweep through the water. Water is much denser than air. This allows short, strong wings to push against it effectively. The penguin steers with its feet, tail, and changes in body position. Its body is streamlined. The feathers form a smooth outer surface and trap insulating air near the skin. A layer of fat adds further protection in cold water. Some species can dive for many minutes. Emperor penguins may reach depths greater than 500 meters. During deep dives, their heart rate slows and oxygen is directed toward essential organs. When a penguin returns to the surface, it may release a trail of bubbles from its feathers. These bubbles can reduce drag during a rapid ascent. The bird rises through dark water, breaks the surface, breathes, and rests briefly beneath the open sky. Fact 23. Flamingos are not born pink. Young flamingos have gray or white feathers. The familiar pink color develops from pigments in their food. These pigments are called carotenoids. They are found in algae and in small animals that have eaten algae. Flamingos filter this food from shallow water using specialized bills. The pigments are processed by the body and deposited in the feathers, skin, and tissues. A well-fed adult may become a deep shade of pink or reddish-orange, depending on the species and diet. In captivity, flamingos need suitable food to maintain their color. Without enough carotenoids, their feathers become pale. Their feeding posture is unusual. The bird lowers its head into the water and often holds the bill upside down. The tongue pumps water through comb-like structures that trap food. A flock may feed together in a quiet lagoon, moving slowly through the shallows. Their color comes from countless small meals gathered from water, mud, algae, and tiny drifting life. Fact 24. Crows can remember individual human faces. Research with wild crows has shown that they can learn to recognize people associated with danger. They may remember a threatening face for years. The birds do not need to see the entire body. Facial features can be enough. When the person returns, the crows may call loudly, gather nearby, or follow from a safe distance. Other crows can learn the warning through social observation. A bird that was never directly captured or handled may still react after watching the behavior of its companions. Crows belong to the corvid family, along with ravens, jays, and magpies. Many corvids show strong memory, flexible problem-solving, and complex social behavior. Recognizing individuals is useful in a world where some animals are dangerous and others are harmless. A city crow may live among thousands of people, cars, sounds, and buildings. Within that busy environment, it can preserve a clear memory of one particular face. Fact 25. Ravens sometimes play. Play is not limited to mammals. Ravens have been observed sliding down snowy roofs, rolling objects, hanging upside down, and playing games with other ravens. Young birds play more often, but adults may also take part. The behavior does not always have an obvious immediate purpose. Play may help develop balance, coordination, social skills, and problem-solving ability. It may also strengthen relationships between individuals. Ravens sometimes carry objects into the air and drop them, then dive after them. They may tug at sticks or exchange objects with a companion. It is difficult to know exactly what a raven experiences during play. Scientists must be careful not to assume that every animal emotion matches a human one. Still, the behavior is flexible, repeated, and often performed when the bird is safe and well-fed. On a quiet winter day, a raven may slide across snow, rise, return to the same place, and slide again. Fact 26. Some birds use tools. New Caledonian crows shape twigs and leaves into tools for extracting insects from holes. They may trim a stem, form a hook, and carry the finished tool to another location. Woodpecker finches use cactus spines or small sticks to reach insect larvae inside wood. Egyptian vultures use stones to break open large eggs. Tool use requires the bird to connect an object with a later result. In some cases, the bird must choose a tool of the correct length or shape. Not every individual is equally skilled. Young birds may improve through practice and by observing others. Tool behavior does not mean that birds think exactly as humans do. Their minds evolved under different pressures, but it shows that a small brain can support planning, memory, and flexible action. A crow may stand beside a branch, examine it, remove unnecessary pieces, and quietly create an object that did not exist before. Fact 27. Birds sing with an organ that humans do not have. The main sound-producing organ of a bird is called the syrinx. It is located near the point where the windpipe divides toward the lungs. Humans produce voice using the larynx in the throat. Birds also have a larynx, but most of their song comes from the syrinx. The syrinx contains membranes that vibrate as air passes. Muscles adjust the tension and shape, changing pitch and tone. Some songbirds can control the two sides of the syrinx separately. They may produce two different frequencies at the same time, or move rapidly between notes. Birdsong is used for territory, courtship, recognition, and social contact. Calls can warn of danger, maintain a flock, or help parents and young locate one another. Each song is produced by small, controlled movements inside the body. Air leaves the lungs, membranes begin to vibrate, and a pattern of sound passes outward through the morning air. Fact 28. Many birds must learn their songs. Some bird calls are largely inherited. Complex songs, however, often require learning. A young songbird listens to adults during a sensitive period. Later, it practices. Early attempts may sound soft and disorganized, a little like the babbling of a human infant. With repetition, the song becomes more stable. The bird compares the sounds it produces with a pattern stored in memory. Different populations can develop local dialects. Birds of the same species may sing slightly different songs in different regions. Song learning is best studied in species such as zebra finches, sparrows, and canaries. The process has helped scientists understand memory, brain development, and vocal communication. Some birds continue changing their songs throughout life. Others settle on a stable version after one early learning period. Before sunrise, a mature song may sound effortless, but behind it lies a history of listening, imperfect practice, gradual correction, and many quiet repetitions. Fact 29. The smallest bird eggs are still complex living systems. Every bird begins inside an egg, surrounded by structures that provide food, water, protection, and space for development. The yolk supplies much of the energy. The albumen, often called egg white, contains water and proteins. Membranes in the shell protect the growing embryo while still allowing gases to pass through tiny pores. A developing chick receives oxygen from the outside air and releases carbon dioxide. Blood vessels spread beneath the shell to support this exchange. The shell is strong enough to protect the contents, but not so strong that the chick cannot escape. Near the end of development, many chicks use a small temporary structure called an egg tooth to begin breaking through. The process may take hours. The chick rests between movements. Inside the quiet shell, organs form, feathers begin to grow, and the body prepares for a world it has not yet seen. Fact 30. Birds often become quiet before they sleep. As evening approaches, many daytime birds reduce their activity. They finish feeding, preen their feathers, and move toward a familiar roost. Some sleep alone in dense vegetation. Others gather in groups that may contain hundreds or thousands of birds. A communal roost can provide warmth, shared information, and protection from predators. Small birds choose places sheltered from wind. Water birds may rest on open water, where approaching danger creates movement they can detect. Woodpeckers and small owls may sleep inside tree cavities. Before settling, birds often adjust their feet and feathers. Tendons in the legs can help the toes remain closed around a perch without continuous muscular effort. The head turns backward. The bill disappears beneath shoulder feathers. The breathing becomes steady. Around the roost, the final calls grow less frequent. Individual movements stop. The branches become still, and the long activity of the day slowly fades into darkness. We have now reached the end of our 30 quiet facts about birds. May the wings be still, the night remain calm, and your own rest come gently. Good night.